most recently, actually today, I finished with my student, Shokruz Kakaru, a new paper that talks about methane that was detected around 3A Atlas. The strange thing about the methane, and it was detected by the Webb telescope. Again, this is a signal, very high significance, no noise. Everyone agrees to that. It was celebrated by everyone. And we see methane only after 3A Atlas passed close to the sun, after perihelion. Why is that surprising? Why is that an anomaly? Because methane is more volatile than carbon dioxide, CO2.
Yeah.
And we saw carbon dioxide even when 3A Atlas was very far from the sun. As soon as it was discovered, back in August 2025, the Webb telescope, the same telescope that is detecting methane, detected carbon dioxide back 6 months earlier when it was a few times farther from the sun. But it didn't detect any methane back then. Methane is more volatile than carbon dioxide, so it can evaporate more easily when it is illuminated by sunlight. How come we didn't see methane, but we saw carbon dioxide, which is more difficult to evaporate? So the answer by the people who wrote this paper about the discovery of methane, and that's the first time methane is discovered around an interstellar object, the answer was, maybe methane on the surface was destroyed or evaporated long ago by cosmic rays hitting the surface. So there was a surface layer that was rich in carbon dioxide, but depleted in methane. So only after this outer layer was evaporated, as a result of the heating, the warming by sunlight, only after you remove this outer layer, you get to the deeper level where you find the methane close to the sun. That was the explanation. The problem is that there was also carbon monoxide detected very early, together with the carbon dioxide. The carbon monoxide is similar in its volatility to methane. So if methane was eliminated from the outer layer, how come carbon monoxide was still there to appear together with the carbon dioxide? So I wrote a paper saying, could it be a signature of life, a biosignature? Because in the case of exoplanets, methane is considered one of the most important biosignatures. It may be the first one to be discovered by the Habitable World Observatory.
Forgive my ignorance, but isn't methane in the same in oil in Earth?
Yeah, but methane on Earth is produced mainly by algae, and also bacteria. So it's produced by life. Otherwise, it's consumed. If there was no life on Earth, methane would be depleted significantly. So it's considered a signature of life if it comes together with oxygen, for example, reducing gases. So I asked, is methane around 3A Atlas a signature that there are microbes maybe in the iceberg, even if you believe it's an iceberg? Because then it may be a way of panspermia, transferring life between the source star of 3A Atlas and the solar system or anywhere else. This may be a way of transporting life between systems. So we did a calculation, and it turns out that there are some organisms that produce methane at a high enough rate in case there is a little bit of liquid water produced inside the iceberg as a result of some processes. You could get the amount of methane produced out of a small fraction of the total mass of 3A Atlas. So the idea would be that these microbes are being revived by the sunlight, and then they produce this methane. And immediately people started being upset about it because the argument was, but methane is also occurring naturally, and it may be locked as ice. So I tried to explain, it's not just making general statements. You have to explain why methane appeared only close to the sun relative to carbon monoxide, carbon dioxide. Yeah. That's what people fail to recognize. They really want everything to conform to past knowledge. And clearly, 3A Atlas is delivering a message that is unusual. But even if the message is unusual, the experts are refusing to admit that it's unusual. They would find a way around it. Another thing that 3A Atlas has is 1,000 times higher deuterium abundance relative to the cosmic value. Deuterium is used as fuel for nuclear fusion, for example. So I did a simple calculation. I said, okay, Edward Teller, during the Manhattan Project, he asked the question of whether exploding a nuclear bomb would actually ignite the atmosphere or the oceans as a result of chain reaction.
Yeah.
In the oceans, the issue was whether it will ignite the deuterium, which is very low abundance. And Hans Bethe calculated, no, the radiative losses from the explosion would cool the material very fast, and therefore you would not get any chain reactions. So indeed, they did the experiments, nothing happened. But on the other hand, if 3I Atlas has 1,000 times deuterium, Edward Teller also proposed deflecting objects like that are aiming towards Earth, deflecting them by exploding a gigaton equivalent mass of TNT next to them by a giant nuclear bomb. So he thought about that as a way of deflecting objects, that just exploding a gigantic nuclear bomb next to them and kicking them. So I asked,
fascinating. Wow.
So I did a simple calculation, tried to figure out if we were to explode that next to 3I Atlas, given the high deuterium abundance, the same as Edward Teller originally worried about in the context of the Earth, whether that would ignite 3I Atlas, the deuterium in 3I Atlas, and create a chain reaction that would make a huge atomic explosion next to Earth. The answer is no, it misses by a few orders of magnitude. It will not ignite, even though the abundance of deuterium is 1,000 times bigger than the cosmic value. We are safe. But I wouldn't recommend exploding a giant nuclear bomb
of course,
because of other reasons. Yeah.